Hi everybody, thank you for watching this video. This is the second chapter of our EVA tutorial. The title of the chapter is Sizing and Oversizing Your Endograft. We are going to talk about several topics today. First, about how to measure exactly the right diameter of our proximal landing zone. Second, about the impact of angulation in our oversizing and some auxiliary products that you have to have available in challenging cases. Third, we are going to talk about the length and the diameter of our iliac limbs. And finally, we are going to describe specific scenarios for aortouniiliac and tube endografts. Now let's talk about the proximal landing zone. The right assessment of the proximal landing zone is sometimes challenging and difficult. However, it is important to measure the right diameter of the proximal landing zone in order to select also the device with the appropriate proximal diameter. The right rate of oversizing, according to the IFUs of most devices, is between 10 to 20%. In practical terms, this usually translates into an endograft that it is 3 to 4 mm larger than the aortic neck. Bench testing has demonstrated that oversizing greater than 20% creates pleats in the fabric and in some endograft was associated with marked increase in the risk of aneurysm expansion and migration. However, you have to keep in mind that in angulated necks, such an oversizing may not be enough to prevent a type 1a endoleak if you are not assessing the diameter of the right landing zone and of the real landing zone. Now let's see how can we avoid such a trouble with our endograft. Let's start with a simple case of a straight proximal neck. In this case, you have to measure the diameter of the aorta below the lowest renal artery and then the diameter of the aorta up to 1 centimeter below your first measurement. You are taking the biggest diameter as a reference diameter and you are making your 10 to 20% oversizing based on the available diameters of your endograft of choice. My personal recommendation is to measure from adventitia to adventitia. There are some endografts where intima to intima measurement is recommended, but I repeat, the general practice is adventitia to adventitia. In that case, we have a proximal diameter of 28.3 mm and a distal diameter of 28.2 mm after 1 centimeter of neck length. The biggest diameter is 28.3. There is some calcification, but no thrombus. Thus, I will perform a 10 to 20%, that means 4 mm of oversizing, and I will choose an endograft with 32 mm proximal diameter. Now, let's go to more advanced case, angulated proximal neck. In case of an angulated proximal neck, it is extremely important to select the right center line if you use, for example, softwares like the TerraRecon, or to rotate accordingly the axis of the Osiris software. Keep in mind about the Osiris software that your center line or your y-axis should be as closely as possible to the position of the Landerquist wire. In order to identify the position of the Landerquist wire before the operation, it requires some experience with EVA procedures. In this case, if you perform your measurements based on the first center line that the software creates, you may have a wrong oversizing of your endograft. The center line provided a diameter of 26 mm proximally and 27 mm distally. The infrarenal angulation was less than 45 degrees. And based on these measurements, the right device that we should choose should have a proximal diameter of 32 mm. Now, if you see the position of the Landerquist wire intraoperatively is near to the left side of the wall And despite the fact that the prosthesis was implanted exactly below the renal artery, the final landing zone does not reflect the diameter of the red line, which was indicated by the software, but it reflects the diameter of the green line. This is the real landing zone. However, there is a difference of 3 mm between the two different lines, from 26 to 29 mm. This changes automatically the proximal diameter of the device that you need from 32 to 36 mm. Here is another example of a severely angulated neck. The proximal diameter is 26 mm, and the distal diameter after 15 mm of landing zone, it is 26 mm as well. Now, you can appreciate that the landing zone of your endograft, it is about 26 mm, that means you need a 32 mm endograft. But if you see the intraoperative angiography, the real landing zone is about 30 mm. That means you need a 36 mm endograft. And if you have chosen the 36 mm endograft, you could avoid a type 1a endoleak. My recommendation regarding such challenging angulated necks: try to keep this oversizing strategy based on the real landing zone, regardless type of the device. I mean, with or without suprarenal fixation. Now let's talk about ancillary products for challenging proximal necks. The next issue has to do with two important devices. The first one is the cuff, and the second one are the endo anchors. These devices are very useful when you have deployed your devices in the most optimal position and with the right oversizing, but you still have a type 1a endoleak. Let's see these types of necks. The first type of challenging neck is the angulated neck. In this case, we deployed the endograft exactly below the lowest renal artery, but there was a slight migration of the endograft. It is common. However, this migration caused a type 1a endoleak, as you see in the final angiography. Here, you have to use again the Reliant balloon catheter, but if it doesn't work, I would recommend you either to use a proximal cuff or endo anchoring. Which treatment strategy you can use depends actually on the distance between the proximal markers of your endograft and the lowest renal artery. If you have enough space, I would recommend to use a cuff. Otherwise, you have to use the endo anchors. Both devices are necessary in case of challenging necks. In this case, we had some space between the beginning of the main body and the lowest renal artery due to the migration of the endograft, and we have used successfully the proximal cuff. You see, there is no type 1a endoleak in the intraoperative angiography. Keep in mind that after the implantation of the main body, the angulated proximal neck has been straightened a little bit, and by this way you can implant more precisely your cuff. In this case, there was a type 1a endoleak, but there was no further ability to implant a cuff, because you can see that the proximal marker on the right side was just below the right renal artery. In that case, you don't have any other option. You have to use endo anchors. And you see that the endo anchors provided a very nice solution intraoperatively, which was durable after 2 years of follow-up. Other type of challenging necks are the tapered, reverse tapered, and bulge proximal necks. In that cases, if you do not have other options by means of open surgical repair or more complex endovascular treatments like FIVAR or CHIVAR, the principle is that you are choosing the largest diameter as a reference diameter for your device. You may need additional endo anchoring if a type 1a endoleak occurs. The third issue of this tutorial was about the length and diameter of your iliac limbs. For this step, it is crucial to measure the right length of the aneurysm sac. Keep in mind that any axial length measurement through your CT scan may be misleading, like in this case, where you can see that through the axial measurement we have a length of 148 millimeter, but if you do it right by the center line, you have a real length of 231 millimeter. Now let's take an example how to choose the right limbs. In order to make it less theoretical, I will take as an example the Endurance 2S stent graft from the Medtronic company. When you decide to plan your procedure, there is an important principle. You have to know exactly the endograft that you implanted. Keep in mind this. In the case of the Endurance 2S, for instance, you have to know that it is a 3-modular system with the ability for in situ measurement on the ipsilateral limb. The maximum of overlapping between the limbs of the main body and the iliac limbs should be 3 stents, and the main body has always a length of 50 millimeter. Each stent of the limbs is about 1 centimeter. Let's take an example of an aneurysm from our first chapter. If we plant the main body of the Endurance 2S from the right side, we have to do following calculations. The length of the aneurysm sac is 112, and the length from the beginning of the endograft and the contralateral gaze is 80 millimeter. That means that is enough space to cannulate the contralateral limb. This is the first point, very important. Now for the left side, the total length is 111 plus 62. That means 174 millimeter. This is the total length between the lowest renal artery and the origin of the hypogastric artery, which will be the landing zone for your iliac limb. Now you have to remove the 50 millimeter of the main body. That means we need a limb of 124 millimeter. Due to the fact that the minimum overlapping is 3 stents, you have to start directly from the beginning of the bifurcation. Thus, you will select an iliac limb of 124 millimeter, and such a limb exists with the Endurance device. Now, for the right side, we have to do some other calculations because you have the ability to use the in situ measurement of the ipsilateral limb. Now, if you look to the aneurysm, the total length is 112 plus 71 for the iliac artery, that is 183 millimeter. This is the total length from the lowest renal artery up to the origin of the hypogastric artery. Now you have to remove again the 50 millimeter of the main body. That means you can start with 133 millimeter length of limb. Due to the fact here that the minimum overlapping is 3 stents, you have the option to start either directly from the beginning of the bifurcation of your endograft or from the second stent of the limb. The ipsilateral limb, keep in mind, it has 5 stents. The appropriate Endurance limbs for this case should be again the 124 millimeter. Due to the fact that the distance is longer than the length of your limb, you can start with the deployment after the first stent. The next issue is, of course, the choice of the right diameter for iliac limb. Here there are 2 important rules. First one, the distal fixation length is 15 millimeter. This kind of, let's say, fixation length is changing between the devices. You have to know it when you're using your device. The second important issue is that the oversizing should be also between 10 and 20%. In order to facilitate your decision, the companies are providing recommendations and tables to choose the right device for the respective ranges of iliac artery diameter. For example, if you have an iliac diameter between 15 to 18 mm, you have to use a 20 mm iliac lip in diameter. Finally, do not forget to measure the distal neck, and in case that you consider that it is too narrow, like in this case for your limbs, just order also balloon expanding stents to implant them in kissing technique upon the results of the final angiography. We have confirmed the efficacy of this technique to keep the limbs patent in the long run. In this case, you see the calcification at the distal neck. In the intraoperative angiography, you see the high-grade stenosis on the left side, and then the balloon expanding stents. These were Genesis stent, and finally a nice result that keeps both limbs patent in the long run. Last but not least, a specific device is also the tube endograft, which is available only by a few companies. The only indications for the tube endograft is the penetrating aortic ulcer of the infrarenal aorta or the aortic stenosis. Our recommendation here is to start from the aortic bifurcations to the renal artery by implanting as many tubes as necessary with 3 stents of overlapping. The rules about oversizing are the same with those of the bifurcated endografts, and the companies that providing tube endografts have these recommendations in tables in their IFUs. Finally, the aorto uniiliac endograft is also a device that has its indication for use. These are the aortic stenosis, the already occluded iliac artery and hypogastric artery, and specific scenarios of emergencies where you cannot gain access from both iliac arteries. In such case, you have to perform a crossover bypass, and you can maintain the perfusion of the hypogastric artery if this is necessary with the so-called banana technique. That means implantation of a very flexible stent graft, for example the Viaban endograft, between the external iliac and the hypogastric artery. As I mentioned also in the first chapter of our tutorial, keep always in mind the C6 P's of the success. Proper preoperative planning prevents poor performance. Thank you for your attention, and keep tuned at Vascupedia. The third chapter about the implantation will be uploaded very soon. You will be informed by our social media channels or in our official website. Do not forget to comment or to ask any questions in our forum below. Be a Vascupedian. See you soon, and bye.